Alright, from 11.5, naming polyhedrons, classifying them, and then counting the number of faces, vertices, and edges, and explaining your reasoning. Mainly, you gotta understand what the heck you're doing. So, this is a pyramid because there's one base, the bottom, that comes to a single point, so that's a pyramid. This is a prism because the rectangles go all the way around, that has two faces that do not touch, they're parallel to each other, which are your bases, is how you name it. That's a prism. And then this thing here is not a polyhedron because of the fact that it is curved. So this is no, curved. This is yes. And I know it's the name of something prism, so I have to figure that out. As well as this is yes. And I need to find the name of the pyramid. Now, in order to find the names, you have to count the base. This base has 1, 2, 3, 4, 5, 6, 7 sides, so it's either a heptagonal or a septagonal pyramid, your choice of which name you want to pick. Faces, the faces are the base and all the triangles that make up the sides. So you have one base here that is 1, and then you have 7 triangles, so there's 8 of them. Vertices, there are 7 on the bottom, plus the 1 apex at the top, so there's 8. Using Euler's theorem from down here below, to get edges, I can count them. There's 7 on the bottom, and there are 7 here, which give me 14. Or what I can do is take 8 plus 8 gets 16, and know that my edges plus 2 equals this number. So if I take faces plus vertices and subtract 2, I will always get my edges, which is 14. Alright, so on 20, I know once again it's a prism because the two bases are the same. This has number of sides, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, so that's a nonagonal prism. So that means there are 9 rectangles that go around, plus my 2 bases, so I have faces equal to 11. Vertices, there are 9 on the bottom, and since there's a repeat at the top, there's 9 there, so 9 plus 9 is 18. Edges, you can take these two numbers, add them, subtract 2, so 11 plus 18 is 29, minus 2 is 27, and that's using Euler's theorem. So jumping down here now to the other part, 11.5, Euler's theorem, find the number that is missing. So faces plus vertices equals edges plus 2. If this is 12 equal to 16 plus 2 plus faces, faces plus 12 equals 18. What number does faces have to be? 6. Faces plus vertices equals edges plus 2. So based on Euler's theorem right here, I'm going to take these two numbers, add 38. So I get 38 minus 2 gives me 36. Once again, so working backwards, you take your edges plus 2 and subtract your faces is the quick way, but if we don't remember, 29 plus vertices equals 81 plus 2, so 29 plus vertices equals 83. Subtracting 29 from both sides, you get 54 equals vertices, so the answer is 54. That's 11.5.